Let's take a look at our kinematics unit assignment in preparation for our test next week. We start off with, as expected, a position time graph. Okay, there's a pretty good chance you could see a position time graph like this on your test on Wednesday. See position on the y-axis, time on the x-axis. What's the manipulated variable here? Time. We know that because we see time on the x-axis, position on the y-axis. We also know by the title. Time is the second variable in the title, which is always the manipulated variable. What's the position of the car at 3 seconds? This is the easy one, right? All we do for this one is go up and over. So at 3 seconds, we go up and over, and we get 6 meters. What's the displacement between 6 seconds and 8 seconds? What do we do for that one? Up and over, times 2. Up and over times 2, and then subtract the 2, right? So at 6 seconds, we get 8 meters. At 8 seconds, we get 10 meters. So we say 10 minus 8 meters is 2 meters. What's the velocity during stage C? Hey, what's the velocity during stage C, or the third stage there? We're going to say for that one, we could say either the slope, or we could say displacement divided by time. I'm going to say displacement divided by time, because I just found the displacement at stage C. 2 meters divided by the time here of, what was it, 2 seconds? Which gives me 1.0 meters per second. And at 7 seconds, we know that's going to be the same number at 7 seconds, because at 7 seconds, it's a constant velocity everywhere between 6 and 8. So if we find the average between 6 and 8 to be 1, then the velocity at that one moment in time, anywhere in between 6 and 8, has got to be 1 meter per second as well. So we're going to say it's 1 meter per second. Now, question E. This is where lots of people made a mistake. The first common mistake that we see on this assignment. What's the acceleration during stage E? Some people did a slope thing. Some people did a, just pick a point and go y over x thing, whatever. In the end, if we have a straight line on a position time graph like we do here, a straight line on a position time graph, what does that represent? Let's go back to the shapes. Okay, go back to the shapes. Position time graph, this, what does it mean? What does it mean? Constant positive velocity. If it's constant velocity, what's the acceleration? 0 meters per second. So there's nothing to calculate there. We just know that it's 0 meters per second squared as it is a constant velocity. Does that make sense? Whenever you get a straight line on a v versus t graph, it's not constant velocity, it's acceleration. Then you got to find the slope or do delta v over delta t. But on a d versus t graph, a position time graph, then it's just 0. What's the displacement of the car over the entire trip? Okay. All we do for this is final position minus initial position. Final position minus initial position. And when we do that, okay, final minus initial position, we say, what is it, 10 minus 0 is 10 meters. Some people tried to find the area of this. If you have a velocity time graph and you want to find the displacement, that's great. Find the area. That's correct. But if you want to find the displacement on a position time graph, don't make it harder than it has to be. Okay, displacement is change in position. If it's position time graph, just subtract 2 positions and get the displacement. Done. And then the average velocity of the entire trip is delta d over delta t. And we found the displacement over the entire trip, it's 10 meters. And the time over the entire trip was, what was it, 8 seconds? 10 divided by 8 was 1.25 meters per second. Each of those were a half a point, but I didn't want to make it out of 3.5, so I just gave everyone a free half a point there. So if you got none of them right, you still got a half a point, I guess. Although there was nobody that got none of them right. The next one, the velocity time graph, let's keep these straight, right? Neither one of these graphs are crazy hard. It's just a matter of keeping them straight here. What's the velocity at 3 seconds? Up and over, it's going to be 6 meters per second. What's the change in velocity of the entire trip? Well, the final minus the initial. The final is 10 meters per second. The initial is 0. So we're going to say 10 minus 0 is 10 meters per second. What's the acceleration during stage A? In stage A for the other graph, there was no acceleration because it's constant velocity. But in this one, it's not a constant velocity, it's a constant acceleration. So we've got a couple of options here. In stage A, we can say the slope is equal to rise over run, or we can say A is equal to delta V over delta T. Delta V is, for during stage A is 8 minus 0, and the time is 4 minus 0. So we're going to say 8 over 4 equals 2 meters per second squared. D, the acceleration during stage B. Not sure what people did here. This was a fairly common mistake as well. People had numbers for this. Okay, what does that mean if it's a flat line on a velocity time graph? The velocity is not changing. It's a constant velocity. And if it's constant velocity, what's the acceleration? 0 meters per second squared. This is where you had to find the area, right? When you find the displacement on a velocity time graph, not a position time graph. I promise you, next Wednesday, you will get either a position time graph or a velocity time graph, or both. Okay, you might get both just like you did here, but I guarantee you're going to see at least one of these two graphs. Okay, so and make sure you keep these straight. Okay, we know what we're going to get. We know the questions we're going to be asked on the position time / velocity time graph. Okay, be able to do it. Let's find the area here. We're going to break this up into a few sections here. And there's a couple different ways of doing this, but the way that I did it was I broke it up into 3 sections here: area 1, area 2, and area 3. Some people broke it into 4. Doesn't matter. Area 1 is 1/2 base times height. The base is 4. The height is 8. That gives me 16 meters. Area 2 is just base times height. 4 to 8 is 4 times the height is 8. Gives me 32. And then we say area 3 is 1/2 base times height. The base is 2. The height is 2. 1/2, 2 times 2 is 2. We add those up and we get 50 meters. So the displacement here, the displacement is 50 meters. Some people did the exact same thing for both graphs, the position time graph and the velocity time graph. And I'll tell you, to find the same variable on one graph versus another graph, you're never going to do the same thing. So if you do the same thing to get displacement on both graphs, you're wrong on at least one of them. Maybe both of them, but at least one of them, you're wrong. Because you can never do the same thing on 2 different graphs. To get the same thing, that is. And finally, the average velocity of the entire trip. We're going to say V is equal to delta D over delta T. The displacement is 50 meters, as we just found, and the time here over the entire trip was 8 seconds. 50 divided by 8 is 6.25 meters per second squared. 6.25 meters per second, not meters per second squared. All right. Number 3. A man walks 100 meters to the north at 50 meters at 30 degrees south of west, then 30 meters to the south. What's the man's total displacement? What we're really doing here is adding vectors together, right? We got 3 vectors. We got to add them together. We got to draw it out first. We got 100 meters to the north, and then we got 50 meters at 30 degrees south of west. This is south of west, okay? Not this, this, okay? If I drew at the second position, that would be west of south. Look, I'm measuring this 30 degrees from the west, south from the west, okay? As opposed to this way would be from the south, or west from the south. So it's 50 meters right there, and then we have another 30 meters right here to the south. First thing we got to do is get rid of that funny angle, right? Don't like it, so we get rid of it. There's my 30 degrees. There's my 50 meters. I was really happy with how a lot of people redrew this diagram. Okay, once we found the x and y components of this, people redrew it over here. We say cosine 30 degrees is equal to x over 50. That's adjacent over 50. X is equal to, what is it equal to here? 43.301. And we'll say sine 30 degrees is equal to y over 50. Y is equal to 25. Walk it off to the side here. Let's replace this. We don't need that 50 meters anymore. Let's just replace it with 43.301 and 25 meters down. And then, of course, we do our thing. right? X components and Y components. 0 and 100, negative 43.301, and 0, 0 and negative 25, 0 and negative 30. Okay, we add these up, we get negative 43, and we get 45. This is negative 43.301. Now, some of you got this far. Some of you got this far. I mean, lots of you got this far and got the correct answer, right? Lots of you did a really good job on it. But some of you got this far and then said, oh, 43 and 45 is 98. What's wrong with that? 43 plus 45 is 98, right? Sometimes. Is 43 plus 45 98 here? Or 88, I should say? No, they're vectors. We've got a vector that's this way, that's 43. And we've got a vector that's this way, that's 45. And those do not add up to give me 88. It's just not. Okay, we've got to find the resultant vector here by doing the Pythagorean theorem. And when we do, it works out to be 62.4 meters. And theta, using the inverse tan function of opposite over adjacent, 45 over 43, gives me an angle 46.1 degrees north of west. Now, I'll tell you what. On Wednesday's test, you are going to get a question like this. Okay, you are. Now, some people were confused, a little bit confused about where that 30 degrees goes. Okay, I'll help you with that on Wednesday's test. Okay, I'll give you I'll draw that vector for you. I will not draw the vector diagram. Okay, I won't draw them the way that I drew it on the board here, but I'll draw the 30 degrees south of west, well, or whatever it is, right? I'll draw it like this, just so you know, so you're clear on what that 30 degrees means. Does that make sense? Okay. Other than that, you got to do everything I did on the board there. You will see one of these on the test. There will be a funny angle. I'll tell you, I'll draw it so that you know exactly where the funny angle is, so you're not confused about that. But beyond that, you've got to be able to deal with the funny angle, know whether you're using sine, cos, or tan, okay? Know what to do with it after that, where to sub it into your x and y components, and then to do the Pythagorean theorem in the inverse tan function. Okay? Number 4. You're going to get one of these as well, by the way. Okay, just telling you, just saying. You're going to get a question like number 4, one of these relative motion / navigation problems. This one says the captain of a ship heads directly north. Heads is that a solid line vector or a dotted line vector? That's a solid line vector, right? Because that's not my actual motion. That's what's contributing to my actual motion. We head north at 10 meters per second. But there's a river current to the east. Is that a solid line vector or a dotted line vector? That's a solid line vector. It's to the east. We have to make solid line vectors drawn front to back or head to tail. So I'm going to draw it like this, 4 meters per second to the east, head to tail. And then my resultant vector, which is my dotted line vector, which is my actual motion, is what I'm trying to find here. We're going to say r is equal to the square root of 10 squared plus 4 squared, which gives me a value of 10.8 meters per second. And we're going to say theta is equal to the inverse tan of 4 over 10, opposite over adjacent, which gives me 68.1 degrees. No, it doesn't. Gives me 22 degrees. 21.9 degrees, is that what it is? 21.9 degrees? East of north. Now, some of you drew it like this and got 68 degrees. Is that right? If you got 68 degrees like this? Absolutely it is. But that would be 68 degrees north of east, not 68 degrees east of north. Okay, both would be absolutely correct, including on Wednesday's test. Now, how long does it take to cross the river? Okay, you guys did a really good job on this. Really nice job on this. We know that we use the equation v equals d over t. We're solving for t. It's d over v. And most of you remember that we have to be consistent with our directions here. If the displacement is across the river of 300 meters, then we have to use our velocity that goes across the river, which is 10 meters per second. Okay, we divide those and we get 30.0 seconds. And how far downstream does the ship end up? Same deal. We just got to be consistent here. If I want downstream displacement, then I want downstream velocity. And my velocity is downstream 4.00 meters per second. And my time interval here, just calculated as 30 seconds, which gives me 120 meters downstream. All right. Number 5, truck traveling 45 kilometers per hour accelerates to a speed of 72 kilometers per hour over a time of 15 seconds. What's the acceleration? What's the displacement? Not a bad question. You guys didn't do badly on this, but the one common thread of people that did make mistakes is, what do you think it was? Converting units, right? Okay, people forgot to convert units. 45 kilometers per hour was, if we convert that to meters per second, 45 kilometers per hour VI ended up being 12.5 meters per second. And we find that by multiplying by 1,000 to get meters, divide by 3,600 to get seconds, 12.5. 72 kilometers per hour, that's VF, is 20 meters per second, right? Times it by 3,600 on the top, 1,000 on the top, 3,600 on the bottom. VF is 20. My time interval is 15. And the easiest way to find acceleration here would simply be to say VA is equal to delta V over delta T. 20 minus 12.5 over my time interval of 15. Do the math there, and it works out to be 0.500 meters per second squared. Okay, yeah, not bad. Not a bad question, but there was a significant number of you, like not half, but a significant number of you, enough for me to remember that issue, okay, that didn't convert. Did everything else right, okay, knew what you were doing on the question, but just didn't convert to meters per second. So be careful on that. I can't remember exactly where you're going to see that, but you will see it on on Wednesday's test. You will see that situation where you have to convert from kilometers per hour to meters per second. Okay? If you're a little bit trouble about how to do that, then just let me know and I can help you out with that. Displacement of the truck. I've got a couple of options here. What I did is said D is equal to VI plus VF over 2 times T. Okay, that works, going back to our original data. But now that you have A, you could also use VIT plus 1/2 AT squared, or VFT minus 1/2 AT squared. There's a bunch of different options now. VF squared is equal to VI squared plus 2AD, I think we could use as well. Okay, all kinds of options now. This one I think is the simplest, but whatever works for you. We say 12.5, again in meters per second, plus 20 in meters per second. And we do that math. 12.5 plus 20 is 32.5, divided by 2 is around 16, times it by 15, and we get 243 meters. Some of you had said 244. I got 243. I marked them both right because I didn't even bother checking the rounding, but is it 243 or 244? We get 243.7? Okay, so 244 is the answer there. Yeah. Thank you. I thought there was a chance of that since so many people had 244. I thought, man, maybe I rounded wrong. And I marked them right either way. So, 6. Ball was thrown into the air with an initial velocity of 18 meters per second. What's the maximum height to which the ball reaches? We're going to say VI is 18.0 meters per second. What else do we have if we read between the lines here? There's a couple things in this question. If we read between the lines, yeah, Blake? Yeah, we get the acceleration. What is it, Blake? Good, negative 9.81 meters per second squared for the acceleration. And what else do we have if we read between the lines here? Maddie? Good, VF is equal to 0 meters per second. Good. We want to find the displacement at that point, right? So what I did in this question is said VF squared is equal to vi squared plus 2ad. And then I rearrange to solve for delta d. What do I got to get rid of first here? The vi squared or the 2a? What's not attached? McKenna, what's not attached to the delta d here? Vi or 2a? So we're going to take that over by subtracting, and we're going to say vf squared minus vi squared equals 2 times a times d. And then we got to do what? Get rid of the 2a. It's multiplied by d, so we get rid of it by? Right. So let's say vf squared minus vi squared over 2a equals delta d. So what do we got here now? Vf is 0 squared minus 18 squared over 2 times negative 9.81. And when we do the math on that one, we end up getting 16.5 meters per second. The time that it takes the ball to go up to its maximum height, then back down to the point where it was released. Here's what I did. And there were, just like there is a lot of times in these acceleration questions, there was more than one option in this. This is what I did, but it's not the only way to solve this problem. I said A is equal to delta V over delta T, and then I rearranged it to solve for delta T. I said delta V. Now watch carefully what I did. I said delta V is minus 18 take away 18. And the acceleration would be negative 9.81. How is VF minus 18? How is VF minus 18?
Because we're talking about the whole time, so it's going down the
Yeah, up and down. If it starts at 18 meters per second on the ground and it comes back down to the ground, how fast is it moving when it hits the ground? Minus 18. 18 in the negative direction, right? That gives me negative 36 divided by negative 9.81, which gives me 3.67 seconds. Now, that's what I did. Okay, that's not what most of you did. What most of you did that did it correctly, that is, was something like this, but your final velocity would be 0. So in other words, you calculated the time that it takes for the ball to go up. And then, what did you do after that? Sorry? You times it by 2, because it takes that amount of time for it to go down as well. That's fine. Okay, that's absolutely fine. How long does it take to go up? 1.8 something seconds. How long does it take to go down? 1.8 something seconds. Add them up, and you get 3.67 seconds. Okay? My way is no better than your way. That's just the way that I was thinking when I did my question. Yep.
Why would the first 18 be negative?
The first 18 is negative because it's actually not the first 18, right? Delta V is VF minus VI. So that first one is negative because it's VF. And which way, Dylan, is that ball moving when it's coming down and hitting the ground? It's moving downward. So VF is going to be 18 down. VI is going to be 18 up. So negative 18 minus positive 18. Does that make sense? Next question, number 7. Soccer ball is kicked with a velocity of 20 meters per second off the edge of a 22-meter cliff. What's the distance the soccer ball travels from the edge of the cliff? Here's the soccer ball. The cliff is 22 meters high. It's 20 meters per second. We know the shape of this, right? What's the shape of it? It's little things like that that we ask in multiple choice, right? Like, I'm not saying that necessarily I'll ask you the shape that it's a, that it's a parabola in multiple choice, but it's things like that. Okay, things that we talk about class like that we can get asked in multiple choice. Okay, Dylan, question? No. So we're going to say, as we always do, and I'm telling you, you're going to get at least one projectile motion question on your test. If you get 2, what do you think they're going to look like? If you get 1, it could be like this, or it could be launched at an angle, like this. If you get 2 of them, then it's going to be one of each, right? So be prepared for both. Either way, you're going to start off this way, x and y components. Christian, what's the x component described by? Which equation? Sorry? What's the equation we use for the x component?
V equals D over T.
Good. V equals d over t. That's what we always use for the x component. And for the y component, we're always going to use what? Good. Now, I'm not going to ask you for the maximum height in this one, right? Because we already know the maximum height. It's 22 meters. So it's always going to be for these ones, these two equations. So in our numbers, 20 is equal to, I don't know what d is, don't know what t is. Go over here, negative 22 for my displacement. The I is 0, because the y component, it's not moving at all, equals 1/2 of negative 9.81 times t squared. Now, I wouldn't say this was a common mistake, but it was a mistake that I saw a few times. Solving for t here. People said half of negative 9.1 is 4.905. Take it over by dividing, and we get 4 point something. Okay, we get 4 point something. Done for time. What do you got to do with it once you take this over by dividing? Square root it. Because then we've got t squared is equal to 4 point something. So square root it to get a time of 2.1178. And then we sub that in up here, and we get a displacement of, what would it be, 42.4 meters. Okay, by and large, you guys did good on this question. Just like the assignment in general, you guys did well overall on this question. And then finally, question number 8. It says a football is kicked with a velocity of 15 meters per second and an angle of 60 degrees. Like this, comes back down to where I started. We got a funny angle, so we get rid of that. This is x, this is y. X is 15 cosine 60, which works out to be 7.5 meters per second. And y is 15 sine 60, which is 12.9904 meters per second. And then we do the same thing as we did for the last question. What's the horizontal velocity here? Not 15. It's gone now, right? It's dead to us. We replace the 15 x component with 7.5. We don't know what d is. We don't know what t is. Delta d for the y component is 0 because it lands on the ground. VI is 12.99. This is where we cancel a t in every term. 12.99 goes over by subtracting, divided by negative 4.905. T ends up being equal to 2.6484. And then we multiply that by 7.5, and the displacement horizontally gives me 19.9 meters. And finally, the max height. For max height, we're doing the y component, where VF is 0. Solve for delta D. Did a problem similar to this earlier on, right? Except it wasn't a projectile motion question. VI goes over by subtracting. 2a goes over by dividing. So we get 0 squared minus 12.99 squared over 2 times negative 9.81. And when we do that, it gives me 8.60 meters. And we are done.